Join Veritech in a new era of automatic identification technology. The Vericode Symbol, an advanced two-dimensional high data density machine-readable symbology developed and patented by California-based Veritech Incorporated. The Vericode Symbol, a revolutionary advance in automated information technology, integrating information systems with today's manufacturing processes. The post-barcode era. The Vericode Symbol's elements consist of a solid frame which serves as the outside border of the data field matrix. All data is contained within this boundary. Within this data frame is the internal data field matrix. This field is comprised of single data cell units which represent binary data. In this code, the data cells are either black or white. However, they do not have to be black or white as long as there is adequate contrast to distinguish a difference. The quiet zone is an invisible border surrounding the data frame. The quiet zone border is the width of at least one data cell. The Vericode symbol is the most advanced and space-efficient of all machine-readable symbologies. The Vericode symbol is capable of representing any information that can be converted into binary format. Data is entered into the system using many methods. The information is converted into a stream of binary data, then encoded and represented by a Vericode symbol. The Vericode symbol can then be transmitted to a device for marking. The Vericode symbol's image is captured and converted back into a stream of binary data by the system controller. The final result can be exported to the user's database or converted into information for a variety of uses such as item sorting or manufacturing process control. The types of information that can be encoded into a Vericode symbol are endless. For example, date and time, which is then converted into binary data, then encoded into a Vericode symbol. The customer has the option, prior to encoding, to specify the type of data contained within the symbol. These options include batch format, where the user's information is the same from part to part, real-time or serialized formats, for applications where it is necessary for the information to change from code to code, and finally, key to a database file, which serves as a license plate for the location of the information relating to a particular item within the user's database. Once the Vericode symbol has been marked on an item, at any time thereafter, the Vericode symbol is captured using CCD machine vision technology. When decoded, the data stream can be exported to the user's database or converted into information that can be used to track, trace, sort, control, program, match, index, access, authenticate, instruct robotics, validate, assemble, verify, inspect, orient, or update. The list of applications and resulting benefits is infinite. Now that we've covered the Vericode symbol basics, let's take a look at some of its features. The Vericode symbol's size is variable. There is virtually no limit to how large or small the code can be configured. The amount of information within a Vericode symbol is user selectable, even in codes measuring the same size. The data density is not a function of the size of the code. Therefore, the user can select the amount of information a given size code can hold. In contrast, traditional barcodes require more space each time the amount of information is increased. The two-dimensional Vericode symbol can be decoded in any 360-degree orientation. No manual positioning of the code is necessary. This omnidirectional feature allows the Vericode symbol to be used for applications such as orientation of parts during automated assembly processes. The proper orientation can be assured at any angle when parts are marked with the Vericode symbol. The code can also be utilized to directly communicate information to robotics in automated environments. This is just one of the many features that sets the advanced Vericode symbol apart from other symbologies. The Vericode symbol's skew versatility gives it the capability of being captured and decoded at up to a 60-degree angle off the horizontal plane. This permits a range of flexibility while still obtaining accurate data. The Vericode symbol is not dependent upon the accuracy of crisp lines on the edges of the code or data cells in order to return reliable data to the user. It is a robust code and only requires part of the data cell to be present for a positive read. Vericode symbols can be configured for reconstructability so that 100% of the data in the code is returned, even if part of a Vericode symbol becomes damaged or is missing. Veritag also offers additional features which further enhance the Vericode symbol's capabilities. These features include variable application formats. This feature allows the Vericode symbol to meet different industry and application requirements and standards. The Verisystem can automatically discriminate between the different Vericode symbol formats. Error detection and correction. This feature can determine if an error is present in the code, correct the error, and return the correct decoded information. In this example, random error cells have been introduced into the code. The correct information is recovered during the decode process. The Vericode symbol will maintain its data integrity even when the code is altered or damaged. This feature is important where accurate information is critical. The Verisystem will either deliver accurate information or no information. It will not return inaccurate or unreliable information to the user. For security applications, the Vericode symbol can be configured for different levels of data encryption. There are 4 basic classes of the Vericode symbol. Macro Vericode symbols are for use in environments that require unusually large identifiers. Standard Vericode symbols are appropriate for situations where limited space is not a factor. On the other hand, micro Vericode symbols are implemented in applications where limited space is a factor. And finally, submicro Vericode symbols are for applications within the microscopic range. These 4 classes cover virtually every possible Vericode symbol application. The Vericode symbol is the only symbology available today that can bridge the gap and satisfy every identification need within the aerospace, automotive, military, medical, electronic, and virtually every other industry. The Vericode symbol can be marked on an estimated 98% of all materials. There are over 35 different methods of marking the Vericode symbol. Let's take a look at some of the options. Thermal printers produce labels on heat-sensitive paper. As heat is applied to various parts of the label, these areas become dark, producing a Vericode symbol. Laser etching is the most versatile method for marking the Vericode symbol. A high-intensity focused beam of light literally vaporizes a thin layer from the surface of the material, creating the image. The dot peen directly marks the material by creating a series of small indentations in the material surface. Microabrasive blasting is a non-contact process that uses fine abrasive particles propelled with a stream of air through a small nozzle tip to engrave the Vericode symbol directly onto the material surface. The Vericode symbol and the Vera system have been validated by NASA. The Vericode symbol marking and material standards are being completed by Rockwell International under contract to NASA. In their evaluations, all compressed symbologies were reviewed and tested, and the Vericode symbol emerged as the machine-readable symbol of choice. Also tested were the Vericode symbol's data structure and format, with successful tests in all known environments. The Vericode symbol is a better symbol by design. The Vericode symbol can be used as either a standalone symbol or in conjunction with barcodes, OCR, or other existing technologies. Any language or character set can be encoded into the Vericode symbol. This symbol can then be converted back to binary form, decoded, and returned into any format that is specified by the user. The Vericode can receive any binary data input from the user's mainframe, PCs, or test equipment. It is the one symbol for multiple surfaces and materials, and is designed for international applications. Join Veritech in the dawning of a new era. The symbology of the future, today.